Hi students, welcome to quick revision of NCERT, and in this session I am taking a topic alcohols, phenols and ethers. This is first part of this topic, and in this part I am discussing a few bits regarding alcohols. Those bits are: first one, introduction, then you can take classification of alcohols, third one is you can take nomenclature of alcohols, and the last one structure of functional group, that's alcoholic group. Okay, let us start with the introduction of alcohols first. Okay, in this introduction we take the meaning of alcohols, functional group and representation of alcoholic group, right, or alcohols. So at first you can take meaning of alcohols. How do you get these? Alcohols are obtained by replacement of one or more hydrogen atoms of a hydrocarbon. It can be aliphatic or aromatic hydrocarbon by hydroxy group. So if we replace one or more hydrogen atoms of a hydrocarbon, it can be aliphatic or aromatic hydrocarbon by hydroxy group, we'll get formation of alcohols. Right now, general formula we can take like R, general representation for alcohols can be taken as ROH, where R is, we can take alkyl, or you can take even R alkyl also. Okay, some examples here. First member in alcohol series we can take it as methanol or methyl alcohol, and the second member you can take it as ethyl alcohol or ethanol. Right, so the next bit we are having is classification of alcohols. So you can classify alcohols based on number of hydroxy groups present. So that's very simple classification. Based on number of OH groups, we can classify them as monohydric alcohols, dihydric alcohols and trihydric alcohols. So as the name suggests here, monohydric means the alcohols having only one hydroxy group present, they are said to be monohydric. An example taken is ethanol. Second one is a dihydric alcohol. Again, as the name suggests here, it contains two hydroxy groups present, right? It is said to be a dihydric alcohol. An example is ethylene glycol, CH2H, CH2H. Third one is a trihydric alcohol. Okay, here it contains three hydroxy groups present. Okay, so it is called or named as trihydric alcohol. One example taken here as glycerol or glycerine. Right, that's an example for a trihydric alcohol. So classification you can take based on number of hydroxy. That's a simple classification. Now in monohydric alcohols we can divide further. So we'll be having two main types there. First one, compounds containing sp3 carbon OH bond, and the second one is compounds containing sp2 carbon OH bond. Right, let me take first here now. In monohydric alcohols, the first main category is alcohols are the compounds containing sp3 carbon OH bond. Okay, in this we can further get three types. The first simple we can take primary, secondary and tertiary alcohols. Second one is allylic alcohols, and third one is benzylic alcohols. Right, so let us take first one now. Okay, primary, secondary and tertiary alcohols. We know, right, only we have taken the same bit, right, like how to classify primary, secondary and tertiary carbon atoms. The same concept we apply here. Okay, in the case of taking first one, primary alcohols, OH or hydroxy group should be attached to a primary carbon. We can define primary carbon as a carbon attached to no carbon or one carbon. It is said to be a primary carbon. And if you are having OH attached to primary carbon, it is said to be primary alcohol. Now the secondary alcohol, meaning of this is OH should be attached to a secondary carbon. Right, this is secondary carbon because it is attached to two more carbon atoms. So the alcohol is said to be a secondary alcohol. Next one, tertiary. We can take OH attached to a tertiary carbon, and the meaning of tertiary carbon is a carbon attached to three more carbon atoms. Okay, that is said to be a tertiary carbon, and if OH attached to that carbon is said to be tertiary alcohol. Right, this is the first one, and you can see in all the cases OH attached to sp3 hybridized carbon atom only, right? Okay, let us take the second in this now. We got allylic alcohols, right? The meaning of allylic alcohols is hydroxy group is attached to sp3 hybridized carbon atom which is next to the carbon-carbon double bond. Okay, this type of structure, or I can take like arrangement, we can take it as allylic alcohols. So let me repeat once again. Hydroxy group is attached to sp3 hybridized carbon atom which is next to the carbon-carbon double bond. Here you got double bond, right? Okay, this is said to be allylic alcohol. And in allylic alcohols also we can divide like primary allylic alcohol, secondary and tertiary allylic alcohols. So I have taken here, you can see OH attached to this carbon here, sp3 carbon, which is attached to only one carbon. So it is said to be a primary allylic alcohol, first one. Just see the second example given here. OH attached to sp3 hybridized carbon, which is further, okay, first it is next to the carbon-carbon double bond, but it's attached to two carbons, right? So it is said to be in particular a secondary allylic alcohol. Let us take third example now. Okay, in this case OH attached to a carbon, sp3 carbon, right? This is sp3 carbon which is next to the carbon-carbon double bond and further attached to totally 3 carbon atoms. So it is said to be a tertiary allylic alcohol. So in allylic alcohol we can divide them into primary allylic alcohol, secondary and tertiary allylic alcohol. Okay, the third one in this now, we got benzylic alcohols. Right, the meaning of benzylic alcohol is hydroxy group is attached to sp3 carbon which is next to the aromatic ring. Okay, OH attached to sp3 carbon which is next to the aromatic ring, it is said to be benzylic alcohols. And again here also, like we applied in the case of allylic alcohols, we can divide as primary, secondary and tertiary benzylic alcohols. Okay, the meaning is same here also, right? Again, OH attached to primary carbon, OH attached to secondary carbon and OH attached to tertiary carbon. So we can divide them as primary, secondary and tertiary benzylic alcohols. Right. Now the second main, in the case of classification of monohydric alcohols, we can take compounds containing, right, you can see the difference here now. We got sp2 carbon OH bond. So previously we had taken sp3 carbon OH bond, and in this case we got sp2 carbon OH bond. In this we'll get only one type there, it's called vinylic alcohol. So in the case of vinylic alcohol, OH should be attached to, you can see this is doubly bonded carbon, right? Or you can take it as sp2 hybridized carbon atom. So this is one example you can take for vinylic alcohol, right? So that's classification of monohydric alcohols. Now the next bit we're having is nomenclature. Right, if we take nomenclature for organic compounds, we can name organic compounds in two main systems. One is common system, other one is IUPAC system. So in common system, alcohols are named as alkyl alcohols. Right, we need to first write the name of alkyl, corresponding alkyl, followed by the term or word alcohol. We'll get what? Common name. In IUPAC system, we need to name like alkanol. And how do we get this alkanol? At first we need to write the corresponding alkane and replace terminal E of that corresponding alkane by, alcohol suffix we're having is OL. So these compounds or alcohols are named as alkanol according to IUPAC system. Right, so let us take now a few examples for naming alcohols. Right, first example is CH3OH. CH3OH, we got alkyl group is methyl. So it should be named as alkyl alcohol, particularly one carbon alkyl is methyl followed by alcohol. So the common name is methyl alcohol. And if you take IUPAC name, first we need to write the corresponding alkane. So this is one carbon, right? One carbon alkane is methane, and replace terminal E by the suffix OL. So we'll get what? IUPAC name for CH3OH as methanol. Okay, right. So that's, remember, it's always one word name. Okay, if we take IUPAC names. Second example now. If we take second example, it's a 3-carbon alcohol given, right? You can take CH3, CH2, CH2OH, right? If it is 3-carbon, the bonding here, CH3, CH2, CH2, we can take this as N-propyl. N-propyl. So the common name for this alcohol is N-propyl alcohol. Okay, and IUPAC name, the rules in naming organic compound by IUPAC system, we got few rules, right, to be followed. Among that, you can apply few rules here. At first, we can select the longest possible chain, right? And if we take longest possible chain, we can take numbering also, right? Here 1, 2, and this is third carbon, right? So it contains 3 carbon atoms, so we can select the root word now. Root word should be prop. Okay, and if you take corresponding alkane, as it contains only carbon-carbon single bonds, so the corresponding alkane will be propane. And the position of functional group is important, right? Is attached to first carbon here, so it should be named as propane 1-ol, because okay, this 1 indicates the position of hydroxy group, okay, in that longest possible chain. So the IUPAC name for this molecule is propane 1-ol. Next one now. So if we take next molecule as CH3, CHOH, CH3. Okay, this is also having 3 carbons, okay, but you can see the bonding, right? OH attached to not the terminal carbon, it's a middle carbon, right? So we can take this group as isopropyl. So the name or common name of this molecule is isopropyl alcohol. And if we take numbering now, this is first carbon, second carbon, and third carbon. So on second carbon, we got presence of hydroxy groups. So the IUPAC name for this molecule is propane 2-ol. Right. Now let us take 4 carbon alcohols. And in the case of 4 carbon, we can take 4 isomers, right? One is N-butyl. You can take this straight chain, no branches involved. It is said to be N-butyl. The next one is secondary butyl. Third one is isobutyl. And fourth one is tertiary butyl. Let us take the first one now. As I said, no branching involved. It is said to be N-butyl followed by the term alcohol. If you take IUPAC name for this molecule, again the same rules, right? On first carbon, we got presence of OH. And it's a 4 carbon chain, so it should be butane 1-ol. Okay, or you can take it as even 1-butanol also. Right, take the second example now. This is called secondary butyl. Why it is called secondary butyl? Because of, you can see OH attached to a secondary carbon, right? This is secondary carbon, so we can take this as a secondary butyl alcohol. And if you take IUPAC name, so you can take numbering, right? So it contains totally 4 carbon atoms, and on second carbon we got presence of hydroxy, so it should be called butane 2-ol. Right, so butane 1-ol and butane 2-ol. Now the third one, we got again isomer, right, which contains the same number of carbon atoms. Okay, so you can see here this group is called isobutyl. Iso, we got even in the case of propyl also, right? Isopropyl. The second last carbon atom, if it is having methyl group present, okay, in that case we use the term iso. So isopropyl, and here also you can see one methyl, right, attached to the second last carbon atom, so it is called isobutyl alcohol. And for isobutyl alcohol, we can take the naming, or can take IUPAC name for this. Let me first take numbering now. 1, this is 2, and 3. So the longest possible chain contains 3 carbon atoms, and it contains one substituent present here, and the substituent is methyl, and the methyl attached to the second carbon, so it should be starting with 2-methyl. Okay, then it contains 3 carbons, so it should be propane, and OH attached to the first carbon, so it is said to be 2-methyl propane 1-ol. right? So the IUPAC name for the isobutyl alcohol is 2-methyl propane 1-ol. Let's go for next one now. Okay, if we take tertiary butyl alcohol now, the group is said to be tertiary butyl. And if we take IUPAC name for this, like we take first longest possible chain. So this is the longest possible chain, right? 3 carbon. So it should be again prop root word we need to select. And the substituents present here, 1-methyl, and we got functional group OH attached to the second carbon. Okay, so you can write the IUPAC name now. It is 2-methyl, 3 carbon chain. We can take it as prop, as it contains only single bonds, right? So it should be propane. Then OH attached to the second position, right? So it is said to be propane 2-ol. The IUPAC name for tertiary butyl alcohol is 2-methyl propane 2-ol, right? Next one now. Okay, the next example given as dihydric alcohol, CH2OH, CH2OH. So it contains 2 hydroxy group present, right? So we can take the common name as ethylene glycol, and IUPAC name for this is, as you can take 2 carbon atoms, so it should be ethane, and OH attached to first and second carbon, right? So it is said to be ethane 1,2 diol. Okay, so if any compound, okay, or any alcohol having more than 1 hydroxy group present, remember in that case we need to retain the terminal E of that corresponding alkane. Okay, so the IUPAC name will be ethane 1,2 diol. Right, the last one we got is a trihydric alcohol. Okay, this is also, you can name it easily, 1, 2, 3. So we got 3 carbon, right? So it should be propane. Then position is 1, 2, 3, right? So propane 1, 2, 3 triol. And the common name for this molecule is glycerol. Right, this is a few examples for nomenclature of alcohols by common system as well as IUPAC system. Okay, we got few more examples here. Let me take that now. Okay, this is very simple. Cyclo, if it is not there, it is cyclohexane, right? And this is obtained by a replacement of one of the hydrogen of cyclohexane by OH. So it is said to be cyclohexanol. Next one, we got cyclopentane derivative. We can see in this case we got presence of OH and 1-methyl. So if we take numbering, as the rule says, carbon having functional group should get least possible number, right? So it should be 1, 2, right? So we got methyl attached to the second carbon and OH on the first. Okay, if methyl is absent, it is said to be cyclopentanol, but you got presence of 1-methyl here, so it should be written in the form of prefix 2-methyl cyclopentanol, right? Okay, and the last bit in this session is based on structure of functional group. Okay, as I'm taking individually, right, alcohols. So you can take only alcohol here. One example taken is methanol, CH3OH. Right, so what to be taken in structure of functional groups? We can take first the hybridization state of 2 atoms. Carbon is sp3 hybridized, and even oxygen also sp3 hybridized. Now if we take sp3 hybridized carbon atom as well as other atoms, we expect the normal tetrahedral bond angle, and we all know the normal tetrahedral bond angle is 109 degree 28 minutes, right? 109 degree 28 minutes, but you can see here the bond angle is 108.9 degree, so slightly less compared to the expected normal tetrahedral bond angle. The reason for the reduced bond angle, right, slightly less, because of, you can see we got 2 lone pair of electrons on the oxygen, right? So because of repulsion between these lone pair of electrons, the bond angle, or can take particularly COH bond angle, is slightly reduced or slightly less than the normal tetrahedral bond angle. Okay, right, and that's one regarding bond angle. The second point to be discussed is regarding bond length. So I don't want to take OH, right? So the more significant here is CO bond, because we need to compare with the phenols. So carbon oxygen bond length is 142 picometer. Okay, just remember, we can discuss, okay, this in the case of phenols, right? We need to compare alcohols and phenols, so you can take that point in the case of phenols, right? So this completes the first part of quick revision of NCERT from the topic alcohols, phenols and ethers. Right, if you like the video, please subscribe to my channel. Thank you.